Here are 5 reasons to start podcasting. First, talk about things that you're passionate about, and you have a lot of information, and also get other people to talk about their companies, the products that they work on, and things that they enjoy doing. Two, establish yourself as an expert. Three, help establish a network of people who are interested in the same subject material that you are talking about. Four, facilitate cross pollination of ideas. So, as more people get on the network and more innovative ideas are shared, there will be more cross pollination of ideas. And five, earn money before the market gets saturated. So there's an urgency for you to get out and start blogging.
Hi. Um, well, your last podcast was really successful, so I want to continue talking to you about um, your work with um, uh, AI and sentence structuring. So, can you explain how you build sentence structuring using the gesture technology?
Um, yeah. So for starting, right? I think first of all, I would like to thanks for the for having me a second time on the show. I think this is a great show, and I could reach out to a lot of people, and I think that is the main motive behind having podcasts is to encourage more and more people to work and learn new technologies. And coming back to your question about sentence structure, uh, that is actually a very interesting question because when you are constructing a sentence, right, you have to take the entire context into picture. So let's say if I say that I'm a good person and I'm not a good person, so there's only difference in one word, as in one extra word, not, which is in the sentence, and which changes the complete meaning of the entire sentence. So it's important for us to have some sort of a passing on of these of the context to the entire sentence, right? So that could be done using a network as RNN or recurrent neural networks, in which the context of the entire sentence is preserved, right? There are a couple of ways to do that, having LSTMs or GRUs, but the basic knowledge or the basic concept behind these RNNs is to make sure that you have the context in the picture as well. So let's say having the entire gesture, maybe coding the entire gesture into a sentence, I have to make sure that the context is in place. So I think that is a bit challenging when it comes in to working with sentences, but I think it's doable. A lot of companies are already doing it. So if you look at Google's text to speech, which means that you just speak and Google is able to translate that into text, and then similarly it's able to translate that into other into different languages, right, from English to Hindi or maybe Japanese or other languages. This all can be done using these RNNs. Yeah.
Yeah. So, um, there was a research that was done out of Utah, and what he discovered was the Indian pictographs. Indian art was really a language, and when he realized that, because the pictographs were describing Custer's battle, there was an Indian battle where there was a group of Indians that were massacred. So it was describing that battle, and he was able to decode from the Indian pictographs the communication. And what he found was that it was very compressed language. That there was about 35 to 1. So in other words, the symbols that were describing that were translated out into English were about 35 words to every one symbol, and so it was a very condensed communication. And then he went on later to discover that the key to unlocking those symbols were in Indian Sign Language. So they found some Utes that were doing different sign languages that were a part of the culture that was kept with a lot of the high chiefs, and as a result, he was able to figure out what those sign language gestures meant, and then he was able to translate that to the pictographs or the hieroglyphs, and then so that he transformed the idea that Indian art was just Indian art, but he's now building this theory that it's a communication device. Like, for example, there was one symbol that said, don't go here because this is an area where there's flash floods. And so they had a little symbol that for flash flood. And he was able to decode that from hand gestures. So going back to what you were saying with recurring neural nets, can you explain, give some examples of some gesture like um, communications, like what one gesture might say, and then how you would connect it into the sentence?
Yeah, definitely. But I think I mean, as you mentioned, it's important for any language to be able to express itself, as well as to do that in the least number of words or characters, because it actually saves time. And different languages have different characteristics of their own. So in terms of, let's say, for example, we'll take English language because I think it's universally accepted. Uh, uh, so let's say if I have a gesture for uh, if I want to signal somebody to come to come to me, or just maybe come to my house or my place, right? And then I have a symbol for not, which is the negative of it. So let's say if I have to invite somebody to my house, I'll just say that you can come to my place at this time, which will have its own set of gestures, right? But let's say if something comes up, and if at home and I'm not free at that time, I have to tell them that first I have to say the negative term, that is don't, and then I have to convey the entire message that don't come to my place at this time, because I might be busy, right? But let's say, what if the person misses the negative word, as in does not get, or he does not look at the signature that I'm making for not, which means that I won't be free. So it's important at that, because the difference between these two gestures is only one gesture, which signals the person to not come at home. So basically, we want uh, a model, right? Similarly, we want a model to learn from the entire, all the gestures, and not just one specific gesture. We may give weightage to specific gesture, like, right? Let's say we by weightage I mean we give some preference. So let's say if in the entire gesture I have a symbol which symbolizes not or don't, so of course I'll come to a conclusion that this is a negative term, right? But let's say if I have two negative symbols, that is, let's say, he is not my friend, which means ultimately he is my friend, because these two negative terms are going to cancel each other. So, and in the entire sentence, we give weightages to these two particular words, because this word can change the entire context of the whole sentence. So similarly, in gestures, we have to capture each and every gesture that we are making, but at the same time, we have to give preference to specific gestures which convey the entire context of the set of gestures. So yeah, that is, so for that we have to come up with a model which is able to have these weightages in advantage, plus it's able to convey this weightage to the entire sentence. So for this are maybe LSTMs, which is long short term memory, in which the context from the previous gestures are taken into account. Or maybe we can go with a GRU, which is a gated regression unit, which also does something similar. But yeah, but the point is, we can give advantages, or we can give certain weightage or preference to certain words, because that conveys the most of the meaning in the entire sentence. So yeah, that's how it's done.
So when you're talking, like, for example, if you say, I'm hungry, and then the next sentence you say, Um, Give me a list of restaurants, and I don't want hamburgers. I'm not hungry for Italian food. Does it, um, would it then be able to know that you don't want hamburgers, you don't want Italian food? So then it says, gives you a recommendation, possibly of tacos. So in other words, there's an
Yeah.
inference, not okay. That means exclude. I've got set theory now, so I'm doing exclusion. So I take the intersection, exclude that out, and that leaves me a remainder options to give a response.
Yes, of course. So let's say in that case, I'll give more weightage to to words in the entire sentence. I'll give more weightage to words like not, or basically I'll give advantage. I mean, give preference to positive and negative words in the sentence. So let's say if I say that I don't, or let's say if I say I'm not looking for hamburgers, the sentence should be able to pick the keyword not and then hamburgers, which means that I can exclude hamburgers from the entire menu, right? At the same time, let's say if I say that I am hungry for Italian food, so I must be able to get these two keywords, that is hungry, which is an which explains to me that the person wants to eat something, and then Italian food. And once I get these two keywords, I know that the person is hungry. He is looking for Italian food, but at the same time, he is not looking for hamburgers. So I'm going to exclude hamburgers from the entire menu, and I'm going to give preferences or give recommendations uh,
Yeah, and
based on his preferences.
I think that that's an interesting strategy. There was some research that was done on neurolinguistics and the association of different words. So, for example, you have nouns, and that what he found was that the brain, when it associates an image, it also associates a word. For example, if I see a hamburger, a picture of a hamburger, then I will have the same neural response as if I read in a advertisement the word hamburger, or may I say with an adjective noun, a juicy hamburger, or a flame broiled hamburger. Um, so you can combine nouns with adjectives. And then he also found that by identifying verbs, that he could connote relationships between the nouns, like what type of action was occurring on that noun. For example, I'm uh, I want to eat now a hamburger, or I want to buy this hamburger. In other words, there was the noun would be hamburger, the verb would be buy. So at that point, maybe the computer provides a data transaction and purchases the hamburger, through a kiosk for the person who can't um, speak.
Yes, of course. I feel this is a great point because if some, let's say, if that's what I think recommendations are based on. So let's say if I want to eat a hamburger, right? So maybe my laptop or mobile can listen to it, decode it, and it's going to give me suggestions that we can book you a table if you want to eat. Or let's say if I want to order something then the computer will suggest that you can call the restaurant up and have your food delivered to you by a person. And yeah, I think I mean these recommendations like these, or choices like these, are going to help the individual as well as the restaurants or other companies that are actually using this data to help somebody and aid the entire technology. But in this case, we have to make sure that the technology is foolproof, and we have to test it on a lot of people and come up with a strategy that and there can be several use cases related to this. So let's say on Saturdays or Sundays, people prefer to go out and eat. So accordingly, the restaurants can increase their service. They can call more staff on the weekends, because just because from analysis of data they know that more people would want to eat in on Saturdays and Sundays. I mean, eat at the restaurant, maybe, and then perhaps on the weekdays, maybe on Thursday, people like to order something and somebody has to deliver it to their home, so they can add more staff who can deliver food to the place. So these kind of use cases are, I think, important, because it helps in providing a much more valuable user experience. And yeah, I think going forward, I think this is how it's going to be.
Have you thought about switching to other types of gestures that people do? We talked last time about gestures when it came to driving, people making hand gestures, when to proceed forward, when to turn, when it's safe. For example, if a motorcyclist is slowing down, he's going to he's going to use his left hand, and he's going to do a diagonal 45 downward gesture. If he's going to turn right, he's going to make a 45 or 90-degree upward angle, holding his arm to the square. What about gestures like in sports? For example, when you're at a soccer game or even at a hockey game or a basketball game, and the refs are making different gestures, indicating different types of calls. If you're not, a very close avid sports fan, you may not know what those gestures mean. And if you had the computer watching the game, it could be translating what those gestures mean.
Yeah, definitely. I think that's also a good use case in because let's say in sports there are different kind of fouls, different rules and regulations, and a normal person who does not watch sports often, or who does not have a lot of interest, uh, can miss out on all these very minor details. But yeah, having a computer system is definitely enticing, because it can not only get the gestures right, but at the same time it's going to also calculate the entire how the match is going on. So let's say if if let's say in soccer, if some team is one down, right, and they have to score another goal, so they'll of course be more aggressive, and in being aggressive they can go for some fouls. So the computer can not only get these gestures, but at the same time it's going to help in analysis that the other team is playing more aggressively. Why don't we increase our defense? In that case, even if they have a lot of attackers, we can have more people defending the goal, and we can still win with the minor lead. So yeah, I think these use cases are important, and maybe going forward in the next match, uh, teams can look at the feed from the previous match, and the computer could be used to uh, get these gestures as well as other analysis on the previous game, and that is going to help eventually in both the teams, because I think it's being done in a lot of sports, where it's important not only to analyze just the gestures but the entire context of the game.
Yeah,
But yeah.
that's what you were saying earlier about sentence structure. It's not just important that it gathered just the gestures, but it's getting the whole context. Can you speak on the reoccurring neural net? How does that get the whole context? Can you explain, give a kind of an overview of what the reoccurring neural net is, and then how it is able to preserve context?
Yeah, definitely. So, what happens in so we have specific networks for specific problems, right? So, let's say if I want to work on image data, it's very useful for me to have a CNN network, which is only useful for getting different shapes, different colors from the entire image, and this has been very well proven. So, similarly, if you want to work with sequential data, let's say by sequential data I mean the sequence of the data set is important, right? So let's say if I say I am a good person, right, the sequence of the all the words in the sentence are important, because ultimately it conveys some meaning, right? So what RNN does is that RNN is a kind of a neural network, but gives the uh, the entire sentence structure. By entire sentence structure, I mean that if we are using CNNs, one image is going to be separate from another image, right? So if I calculate if I've done some calculations on one image, when I move on to the next image, there won't be any information passing from first to the second image, right? We only have weights, and the weights are adjusted according to one image, and we are trying to fit the similar weights on the second image. However, in RNNs, what happens is, let's say if you have two images and if you have an RNN, so you will have the weights. We can look at the first image.
Okay.
We'll adjust the weights in the system, but at the same time, some of the information from first image is also transferred to the second image. So you have the weights as well. The weights are adjusted at the same time. Some information is being passed on from first image to the second image, right? And that is a very important factors when it comes to working with sequential data. And once this happens, it becomes very easy for somebody who's working with less text language, sentences, sequences, uh, to build a good predictive model, because I'm getting context for each and every data point that I have in the data set.
Right. So I can see now what you're saying. The good classic example would be kind of like a decision tree. For example, if you say, I am a good person, uh, so it would then take the noun I, meaning that David, am, uh, referring to a self-reference. So I pass David
Yeah.
to am, and then it would say good person. So there might be a decision tree that occurs. If he's a good person, then you say welcome, welcome. If you say I am a bad person, you might say please go away. So um,
Yeah, yeah.
so the pipeline is feeding into one data set into another, and so it preserves the context. So the whole sentence
Yes,
structure
yes.
has to be maintained to get the final conclusions. Have you thought about how Google is using the open AI to do things like legal parsing, where it's looking at the context of sentences and then trying to decide if there's non-disclosure context, if there's missing phrases, if there needs to be, if there are certain phrases that are going to be used, maybe even to scan court documents or case documents looking for precedents, so to establish a legal precedence. I know there was a company in London that did this for parking tickets. So it looked at all the legal statutory statutes, and it went through and looked at sentences, and then it found sentences that it could use, and then it presented those sentences in the form of a case brief and helped people not have to pay parking tickets. It reduced quite a few. It's a significant percentage. Have you thought about how this type of reoccurring neural nets could be applied to like contracts?
Yeah, definitely. So yeah, but to answer your question, I'll go back to how RNNs work, and it's so RNNs are not only used for sentences, right? You can even use them in videos. So let's say if I have a video of a person playing, let's say soccer, and I have a video of a person playing, baseball. So in both these cases, just looking at one image may not be able to give the entire the activity. So it's important to have a sequential model which analyzes each of the frame, I mean each of the image in the video, frame by frame, and then use the context to pass on meaning, right? So it becomes easier if you want to classify or if you want to work on certain videos, right? So yeah, so hence RNN are very useful in these cases. And coming back to your point on contracts, yeah, I think it's important, and it's also very it has a good use case. So let's say if I have a contract in let's say in Spanish, right? Maybe the contract was done in that way. My client is from Spain, and all the official work is done in Spanish language, right? And thousands of contracts. So it will be difficult for somebody, for me to hire in India, who knows Spanish and is also familiar with the all the legalities of how a contract works, right? So it will be difficult for us to hire to find or hire a person or train a person who knows Spanish and also has legal expertise. So instead of doing that, what I'll do is maybe I'll just come up with a system of using machine learning, and I'm going to feed my machine all the Spanish, let's say, texture, all the text, and map the language of Spanish to English, so that I can easily get a translator which
Mm.
can translate Spanish to English. But at the same time, I can also give him some knowledge about these um, uh, legal, maybe feed them some legal textbooks and get information out of them. But yeah, so in this case, even if I don't have somebody who's trained in Spanish language, nor is very good in handling all the legal documents, I can use a machine to simply train my network to read the Spanish language, convert it to English, get the get whatever the legal test cases that are part of, I mean, that are in the contract. What do they mean, and what will be the implications? So yeah, I mean, people have done that. A lot of companies are doing something like that, and I feel that there's a lot of scope going forward with these technologies.
Yeah, that's what I was going to say. That's a good use case study of RNNs, because the reoccurring neural net could, when it sees a Spanish phrase or an Indian phrase, it could translate the word, just like we were talking about gestures translating. It could translate or map one language into another language. So then, universally, if for example the software is looking for certain exclusion phrases, like if it sees the word, uh, you will not use this information, or if it's like for example where you said the not, it could look for phrases that are exclusive, and then identify those as important, so that it could be like in a non-disclosure clause. And it also could be looking for things like penalties or terms or dates, because the contracts are constantly changing, and the lawyers are having to adjust the contract based on, for example, if a certain piece of work is not completed by a certain time, there is a penalty, uh, or if there isn't a certain level of satisfaction, there may be a penalty. And all these types of things that are written in the contracts that are constantly changing, it would take a person a long time to have to read the contracts over and over and then make adjustments to the contracts. Where if the machine was doing the translating to English, then it was searching the context for things that it could be say positively, that this is an exclusionary phrase, or this is a penalty phrase, or this is a precedence phase where it has to have a set of cases that proceed to establish a precedence. Those are things where I could see where RNNs could be very valuable for saving time.
Yeah, definitely. I think with RNNs, if there are different use cases, but definitely because there's a lot of text data that is in the world, and not a lot of people know how to use it. But let's say if we have these technologies, it's going to help knowledge out of them, and maybe help them in and other structures. Because let's say 10 years ago we could not think of something which could translate from a different language accurately. So it was important for companies to hire people who were specific, who were only translators, and they also needed to have the knowledge of the product and the field in which they were working. So it was difficult to get somebody who was like that, and also train them, keep training them, and that is an additional cost to the company. But yeah, with RNNs, we can just simply use a model which knows a lot of things on its own. We can train it for a while, improve the accuracy, and just use it on the go. It becomes easier for both, the company and the person who is being trained. Becomes easier for the entire process becomes easier and much cheaper.
Have you thought about translating or doing a little experiment on Old English translation to modern English? For example, if you had the Old English Shakespeare and
Yeah,
you translate it to a modern English to explain what the Old English is saying, because sometimes there's phrases that are referring to things that are historical, geographical. It might be even related to certain types of uh, phrases that we don't speak, but were meaningful in the Old English. And so as a person could use the RNN to actually understand, almost like a dictionary translation. It'd be better than a Tharis, because Tharis would just give you equivalent words. This would actually kind of explain to you in simple English what was being said.
yeah, definitely. I think there are a lot of good use cases for English, old English to new English. But yeah, I mean, I did work on something similar. It was converting Shakespeare, not converting, but it was more of a story forming. So let's say I trained my network on Hamlet, and so basically my model knew a lot of words that were in Hamlet. Okay, and it also had the context of the sentences in Hamlet. So what I did was I gave the opening lines to some sentence, maybe starting with countryman, and then I would ask the model to complete the entire, the entire scene. So the model knew that I have given him 3 or 4 words, and he has to generate, let's say, 100 more words, which should be meaningful, and at the same time, it should be in Old English. That is in how Shakespeare used to write. So yeah, so this is more of just for fun, and there was not a lot of uh, you know specific use case, but definitely, let's say if I'm able to map the English language into the Old English language, right? It will be easier for me to write something in English, and I can have the translation in the Shakespearean language. And I think it's very interesting, because similarly we can use similar approaches to convert or translate from different languages to different languages. So yeah, I think this is important because earlier we used to depend on our teachers and the textbooks to give us detailed answers. But yeah, we can use techniques. You can use these RNN techniques to get us a model to have some sort of translation between Old English to New English. Here.
Well, our time's almost up, but I think you've raised some really important questions about the machine in terms of helping us understand context, because that's where I'm starting to see a lot of monetary value for machine learning, is that it can understand the context, like you were saying with the video in sports analysis. It could be a machine learning broadcaster who's telling us what just happened. For example, if there was a foul, what caused the foul? It's got the whole context. It could say, well, player drove down the lane. He hit the player B with his forearm. You can see at this video frame him
Yeah.
hitting him with the forearm. Ref saw that action according to rule whatever in the basketball player handbook. It says if you do a forearm with excessive contact based on the velocity, whatever, it determined that there was contact and a foul was called. You could also apply this to driving too, in terms of a context when you come to an intersection. Four cars come to intersection. Uh, uh, the car to the right ride first, so the car to the right has the right to proceed into the intersection before the other cars. So there's a context then. It's not just seeing four cars and then trying to figure out who's going to go based on who's moving out into the lane, but maybe it's also using context to figure out what the rules are.
Yeah, definitely. And I think one more use case that you mentioned was to have automatically. So instead of having commentating, right, you can just train on, let's say, if you are a soccer fan, you must have played FIFA. So we have commentaries related to a specific action, right? So we can train a network to learn these mappings, and whenever, let's say, if a person is about to score a goal, the commentary will account that into his to the actions, and then the commentary will be done accordingly. So I think that is also a good use case to have.
Okay. Well, thanks, Ashkay, and appreciate your time, and thank you for being on the show.
Yeah, no problem, David. It's always a pleasure.
Okay. Bye bye.
Yeah, bye.